Well, good morning. Welcome to the prototyping workshop with Team 1038 hosting in the fall of 2013. I'd like to cover a few basics on prototyping that I hope are helpful. Maybe some things you haven't seen, maybe some things you've worked with quite a bit. Mainly just to introduce different materials that are used in prototyping. And first of all, I just want to ask some thoughts on this about this. Why do we prototype? Yes?
So that if you just built one thing, it would probably have a lot of bugs.
Absolutely. We've gone down that route before where you make one item and you think it's the idea, and if you haven't tried to prototype a few solution options, you get locked into something that maybe takes you down a road you don't really want to finish up on. So that's a problem sometimes. So yeah, to help give you a lot of ideas. And it can also prevent you from not being able to let go of your baby, your idea. I'll do this in class sometimes. If you start off on your one idea and you keep developing it, and pretty soon you start holding that baby. Pretty soon that's your idea, right? You don't want to let go of it. So I think prototyping and multiple solution options help break away from that to help you expand your thinking of what it could be. There are a few videos I want to show throughout this just to give an idea of what other teams have done with their prototyping, just to show how simple or how complex you want to go with it. And the first one here, just a short little video clip.
Okay, I'm recording.
Okay, I'm going to freeze right there. Not too complicated, is it? Good old duct tape. You can't beat duct tape. They're actually using the spool of the duct tape as well. Have a wheel. Simple piece of, I think it's EMT, ply, and some 2x4s. So,
What's EMT?
just the, what is it, something metal, electrical metal tubing? Is that what it's?
Yeah, electrical mechanical tubing.
Electrical mechanical tubing. Just a galvanized type tubing that's available. Let's look at one more. We'll finish this up.
Perfect. Yeah, right now.
Okay, anyway, this is Team 51-3's ball, blocker, there we go, blocker. And basically what's going to happen is that we're going to have a pulley mounted down here, which is good enough to be able to pull this spring and the flap down, allowing that the ball can't go in. And then when we want to, we would just release the string onto the pulley, and the spring would pull the plexiglass or plywood in this instant up and allow the ball to go through the bridge.
What else are we going to use it for?
We're also going to use this to pull the bridge down. So this is going to be at 14 inches high, which is the height of the bridge. And when we want to push the bridge down, we're going to come up to it, open this up, well, obviously before that, and then we're going to pull this down.
Okay, stop right there. This is just to show the use of the extruded aluminum piece, and there's an example of it. Has T-slots on it. Rather expensive, but it's very durable and something you can use over and over and over. Many different years. You can reconfigure it many different ways. But you can see that's what they're using here. And it has these adjustable sliding pieces that are very great for prototyping, in that you can make many adjustments. And of course, the human foot. Perfect. Okay. Let's talk about some of the materials a little bit. One of the most basic ones that we use is balsa wood. You have balsa wood kits over that you use? Yeah, they're nice. Hot balsa wood and hot glue, you can't get any faster for prototyping. It's just very quick, it's light. I wouldn't say it's inexpensive though. Balsa in general can be expensive, especially when you're buying bulk balsa wood. I guess it can be inexpensive compared to buying a Vex kit. But good old balsa, tongue depressors, simple items for when you first start prototyping. I like, and I use this in my class, just going to a furniture store or to an appliance store. They have packaging material that's very, very stiff and durable. I mean, cardboard in general is great for prototyping. But more than just cardboard, you can get very, very stiff pieces here that are strong and free. Operative word. So very durable material that you can work with. Also this honeycomb type material. Furniture stores, packaging stores, H.H. Gregg, those types of stores, they have this stuff all over the place, and they're pitching it, and they're glad to give it up. Another one that we use quite a bit is foam core, and different versions of foam core. I think this is foam core here, but there's also this material here. You call this wax board? I think it's called wax board. It's like a honeycomb on the very edge, and just good for prototyping. A lot of side pieces, you need to cover something up. But also you stack it up and you have a durable material that can make bulk size that you need. All right, let's get into a little bit of the foam. I thought I'd bring in a foam cutter because most of us have access to the scroll saws. It's a great one. Bandsaw, obviously, drill press. Basic tools that we have. You guys have scroll saws or a bandsaw? Do you? Okay. Foam cutter is another piece of equipment that can be handy for prototyping. Very simple operation. Heats up a wire, very fine wire. You can get foam again at any hardware or not hardware, well, hardware stores, yes, like the pink foam, yes. Or even appliance stores, the packaging. They always have foam with them somehow. So you can pick up a lot of foam parts, and the beauty of it is just the ease of shaping your part. So this is just throwaway foam. I forget what this was packaging. Probably something unpackaged at school. But it'll cut the pink foam board as well, the insulation. So very nice tool for chunking out, especially thick pieces quickly if you need a shape for it. I really like it.
Now, Doug, will that work with all kinds of foam, or?
Well, you can't use it with polystyrene type. Yeah, you couldn't use it with the foam core. I mean, if you ripped off the paper, you know, it would.
There's like polyurethane foams too, but it's not
I don't think I'd use it with that.
polystyrene.
Yeah, polystyrene, you know, it's, I guess they have closed cell and open cell type foams. But I found with this type foam, also that real flaky, I guess that's a form of polystyrene. It's almost like what they make out of styrofoam cups. And you see that at Lowe's and Home Depot as well. It's not very dense, but it cuts easily on this, and the pink foam does. I would definitely use it in a place where you have a little air movement, though, because you don't want to do it in a closet.
Yeah,
Right.
because I think the hot wire actually goes above the unzipping temperature of polystyrene. You get monomers. So, I believe.
Okay. All right. Thank you. Who wants monomers? Down, huh?
Yeah.
Okay, of course, who cannot leave out in basic prototyping ideas? Good old Legos. Perfect. You have an idea, you have a concept, It has so many different mechanical motions you can try and test with Lego materials. It's limited, limitless on what you can do with it. But again, a little more expense. I'm talking free stuff here. Now you're starting to buy items. If you want to get into VEX parts, VEX is the next level up, I think, on prototyping that really mimics close to what we do in FRC. You know, as far as mechanics and the motion, the bearings, or different bushings you can put on it, mechanical linkages. So just an awesome material to provide prototyping with. And I think it's pretty durable too, as far as what you want to do with it. This actually, with VEX, if you're not familiar with it, you can actually hook up motors to it. It has a programmable controller, and the program is Program C. I believe that it works with it, Program C. And so very versatile. But also just the FTC kit is good in itself. Cost-wise, I would say this is first, and probably your FTC kit, expense-wise, would be the next level up. All right, I did want to go to another video. And I like showing the videos. It's sort of like a picture's worth 1,000 words, to just show how folks are prototyping. Some of this is like, okay, yeah, we've done that. Maybe you see some things. Cool. Okay, very short. Let me go to the next one.
All right, go.
There we go.
All right, do it again. Not good idea. Get more than 1 second. Yeah, get more than 1.
Why is it not expanding?
All right,
Go. Dude, they should write a book about us. Ready?
Yeah.
This just proves the point that prototyping can be fun.
No, it doesn't look for that, because these are rubber.
2 drills, axle, wheels, 2x4.
To be honest, this is
Hey, this one is screwed up.
what?
Yeah, no safety.
Yes, might we point out, please wear safety glasses. Pull your sleeves up.
It's not even a press fit, it's like just sitting there.
Okay. Yeah, we don't claim credit for the lack of safety of other teams, right? All right. Let me show you a few devices that we pulled out of our boneyard. And I forget, this was used, I believe, where we had to go up a ramp. And so basically, just using 2x4 nuts and bolts, a few pieces of aluminum, simple roller wheel, and for our mechanism that we need, so it was just straightforward. Drilling, attaching bolts. You can see the multiple holes where we've tried different angles just to get the right orientation that we need. That's the beauty of prototyping with a big piece of plywood. Because you could try multiple areas where you attach different.
How does that actually work? What are you doing there?
Well, I'm just moving it here up and down.
What were you trying to?
Oh, this was a device where we had to hit a ramp and we had to raise up, I forget what it was, we had to raise up exactly. We were trying to get this mechanism raised up as it hit a ramp. And so this had to go up, but it had to also go over top of a bumper. So that's the reason for that cutout area right here.
So you had motor like driving that down to lift you up?
Well, actually, it was the hitting of the ramp raised this up, is what raised it up.
Bridge too far.
Yeah, it's a bridge tip, right. This device was something we were making when we had to shoot a basketball. And the beauty of it was that we did not know exactly what angle to use yet, so we could just keep adjusting it out to where we needed to. So just a piece of flexible polycarbonate attached to a few cutout arcs, and we could adjust it to where you got it just right. Then when you made your actual part, you knew the angle that you wanted. So another beauty of prototyping. That's the reason we do it.
Kind of like a big protractor.
Yes. Another type of foam, easily cut on the wire cutter. Just pool noodles. Simple. Of course, PVC. Relatively inexpensive, rather rigid. You can easily cut this, shape it. Has all kinds of fittings that you can get for it. Show you one that maybe you have not used before that we like. Eagle belting comes in various sizes. Either have a flat belt, this different diameters of belting. You can also get it in a V-belt arrangement. And the catch, though, with eagle belting is that you have to have a tool called an eagle belt splice kit. And the splice kit has a way to cut it in two. And it has a device that you hook up both ends of the eagle belting, either side. I melt both ends of the eagle belting. I pull it out, I squeeze it together, hold it for a while, let it set up, and then what I end up with is a joint that is just as strong as the part itself. So there's no weak point on this belt. So if you need to transmit power from one place to another in a prototype, and you don't have a big enough rubber band, right, or the exact size, eagle belting is really a fantastic way of doing that. Because you can not only transfer this way, you can reverse the direction, you can turn multiple parts at one time. So imagine having a giant piece of plywood and multiple pulleys on here just to get the orientation of different drive systems that you want to have. So this is very versatile to have. We've had this around for quite a while. We use eagle belting in the final product, but it's also good in your prototyping as well.
How expensive is that?
You know, I'm not certain, but it wouldn't surprise me if this costs $300 or $400 for a kit.
We're moving up the price scale.
Yeah. Any idea? When you guess?
I'm looking it up as we speak.
We're looking it up. My guess is for Eagle Weld Splice Kit, it's called Eagle Belting Company. It wouldn't surprise me if it's $300 or $400. But once you get it, you have it for multiple seasons. I'll finish with one of my favorite tools. Hot glue gun, prototyping. Can't beat it for quick prototyping, putting together ideas. I would suggest that when you prototype, and we've done this in the past, is as soon as you know the dimensions that you have to work within, make a box that's that size, out of cardboard, out of foam core, and that instantly gives you a visual reference to see how much room you have to work with, especially if you cut out big windows in it. So you have a box, if you're dealing with 3 by 3 by 5, everyone gets a visual idea rather quickly where items can be placed and where they have to share room in the bot. And so just right off the bat, having that foam or cardboard box can really be a benefit visually for all the teams with the subsystems to see how much room they have to work within and to deal with it. Well, that's all I have on prototyping. Wish you guys luck in your season this year, and Thank you for coming.